Okay, so welcome back. Now what we're going to do is we're going to talk about transcendental functions. So I'm going to just talk to you, so make sure you take notes. For example, when we talk about trigonometric functions like sine, tangent, realize that those are either going to be oscillating functions, like in the case of sine and cosine, where they don't approach any particular number and they don't go off to positive infinity. They're periodic or sinusoidal type functions. Then you have functions like secant and tangent and things like that that have an infinite number of vertical asymptotes. Okay, so again, they don't approach any particular value and they go off to, well, in that case, they really don't approach, they'll approach infinity on a particular interval, right? For example, tangent is between a negative pi and a half and positive pi and a half, okay? So you've got those types of functions, okay? Then you've got functions like the natural exponential functions, e to the x, and then you've got the natural log functions, ln of x, okay? Now again, you should know the behaviors of those. For example, exponential functions are growth functions, right? Exponential growth if x is positive, exponential decay if x is negative, okay? So you've got to understand the behavior of those graphs, okay? You should know the behavior of those graphs from your days in college algebra and pre-calculus. Now, log functions are the inverse, right? So the natural log function is the inverse of the exponential, the natural exponential function, e to the x. So again, you've got to use what you know about the behavior of those, okay? So I'm going to do an example involving e to the x, and what they want us to do is they want us to find the limit as x approaches infinity and then as x approaches negative infinity. So this is how you have to handle exponentials. Okay, so if I want the limit as x approaches positive infinity of f of x, right? Well, I've got this e to the x, right? So what happens to e to the x as x goes to infinity? Well, it goes to infinity, right? Well, if I just take the limit as it is, I'm going to get infinity over infinity, which is in an indeterminate form. So that's not going to help me. So I've got to be able to manipulate this somehow so I'll be able to simplify the expression where it's going to tell me what the limit is going to be. Very similar to what we did with polynomials, right? Rational functions involving polynomials. Now, in this case, what I'm going to do is I'm going to divide everything by e to the x. Okay? So, this is going to be the limit as x approaches infinity of what? Well, I'm going to divide everything by e to the x. Oops. Okay, now, this is going to equal the limit as x approaches positive infinity. Now what happens to the expression? The expression now becomes what? 2 over e to the x plus 3 in the top. And then this becomes 7 over e to the x minus 5. Right now, since x is going to positive infinity, e to the x is also going to positive infinity. E to the x here is also going to positive infinity, of course. And so what happens to these two fractions? Both of these fractions are going to 0. And so what do we get? We get, negative 3/5. Okay? And so our answer is negative 3/5. Now, what happens if I change this to negative infinity? Well, now, this is still going to negative infinity, right? E to the negative x is going where? Well, it's the inverse. It's a reciprocal, right? So now, if this is e to the negative x, that's 1 over e to the x. Right? And 1 over e to the x, as x goes to negative infinity, is still going to 0. Which means this is going to infinity. And this is going to infinity. Okay? So how do I handle this? Because now it seems like I got infinity over infinity, right? So again, so when you're dealing with x going to negative infinity, you have to understand that e to the x is going to 0. Okay? So how do we see okay, so how do we do this? Well, in this case here, guess what? Okay, now if we look at this, if we realize that as x goes to negative infinity, e to the x is actually going to 0, right? Because if x is going to negative infinity, well, this is e going to e to the negative of a negative value, right? And so this is actually, we're dealing with 1 over e to the x, which goes to 0, right? So again, you just have to remember or keep in mind that if x is going to negative infinity, e to the x is going to 0. If x is going to positive infinity, x is going to infinity. If x is going to positive infinity, then you're going to have to do this method, where you're going to divide the top and the bottom by e to the x. Okay? If x is going to negative infinity, then guess what? You don't have to manipulate anything because these are going to 0 And so you end up getting 2/7. Okay? So be careful. So just make sure you remember that. If x is going to positive infinity and you've got something that deals with exponentials, right? And it doesn't matter if it's e to the x is common, okay? But it could be some other value, 2 to the x. Okay? You just have to know the behavior of the exponential function when x is either negative or positive. Okay? So remember, if x is negative, you've got a decreasing function. So it's heading towards 0. If you've got x is positive, then you've got an increasing function, and x is going, or e to the x is going off to infinity. Okay? And that's it. Have a great day.